Hey everybody, this is our series in sequence units. This is our second video for geometric sequences, and this is video 5. We're going to be working on geometric means today. So let's go ahead and have your notebook ready, but also make sure you have got your calculator, because that's really going to help us, because we're going to be using division and multiplication and stuff, and that one, just to be a little more accurate and make sure that we're right on with our work. So grab your calculators. Alright, so we're going to be finding specific terms in a geometric sequence, and we're also going to be looking for geometric means. So let's get started. Alright, so here we have a sequence, 24, 6, 3 halves, 3 eighths, and we have to find the 10th term in this sequence. So what we're going to do to start is we're going to go ahead and write our explicit. So that's very important. To find any term, we want to start with our explicit. Our explicit definition is a sub n will equal the first term times the r value to the n minus 1 power. So I have my first term to be 24, and I'm going to have to identify my r value. So remember, to do that, you're going to take the second divided by the first, so 6 over 24, and that reduces to 1/4. And I definitely want to double check this, that I'm going to take 3 halves divided by 6 and check that one out. So go ahead, make sure you're using parentheses. 3 halves divided by 6, and I again get 0.25 or 1/4. Okay, and then so that's my r value, and then we're ready to go ahead and write the explicit. So my explicit formula is a sub n will equal 24 times 1/4 to the n minus 1 power. At this point, I'm ready to substitute in 10 because I want to find a sub 10. So 24 times 1/4 to the 10 minus 1 power. I definitely recommend you actually make this a 9 when you type it in the calculator, or otherwise you have to use an additional set of parentheses to mark that that's the exponent, unless you have the new operating system. Alright, so we're going to do 24 parentheses. Now you may type in 0.25 or you may type in 1 divided by 4. Regardless, make sure you've got parentheses, to the exponent, so power of 9, and it gives me a crazy number. We're going to go ahead and try to put that into a fraction, and it actually doesn't allow me to on my calculator. Yours might have a different operating system and allow you to do so. So what we're going to do instead is we're going to write this as 24 over, and this is going to say that I have 9 ones, and 9 ones doesn't change anything, but it also says I have 4 to the 9th power. So it's not 49, it's 4 to the 9th. Now to fix this, I'm actually going to try to figure out what 4 to the 9th power is. So 4 to the 9th power is 24 over 262,144. Okay, now we could take this one extra step and reduce it by just dividing each of those. We know they're divisible by 4 because 24 has a 4 in it, and they'd probably be divisible again by another number 2. So we really could divide this by 8 and simplify it a little bit more. I'm going to let us leave it. Let's try another one. Alright, so here it looks like my r value, if I go from -3 to positive 12, is -4. And here I'm going to go 48 divided by 12, that's another -4. Okay, so r equals -4. I want to find a sub 12, so let's go ahead and write my explicit. A sub n will equal the first times the r value to the 12 minus 1 power. Go ahead and type that in your calculator carefully and see what you get. Because this one's not a fraction, it actually comes out pretty nice, and it does come out to a positive value of 125822912. I'll go back and stick in some commas so we can pronounce it correctly, and it's 12,582,912 is the 12th term. Okay, next one. I'm going to divide 6 divided by 4 gives me 3 over 2. 9 divided by 6 gives me 3 over 2. So it looks like here I've got I've got my pattern, my R value. My R is 3 over 2. My A value is 4, A1, excuse me, so my explicit A sub n will equal 4, parentheses 3 over 2 to the 18 minus 1 power. Let's see what that gives us. Okay, gives us a pretty big number, and it gives us a decimal that follows. It does allow us to write it into a fraction, so I would prefer the fraction answer. Although actually on this one I might prefer the decimal because it did lead us to decimals in the original sequence. So let's stick to that. If the original is given in decimals, then we're going to stick to decimals. So it's 3,941.045013. And that is the 18th term in our sequence. Sorry, that was the last video uploaded. Okay, now we're working on geometric means. So very similar to how we worked with arithmetic means is we're going to have to figure out how many R values we would have had to multiply by. Okay, now this also comes, I'm going to show you that idea is that I'm having two R values to get me from the first to the third. So I'm going to start by saying, well, 20 is the result of starting at 5 and multiplying R times R, which is R squared. So I'm going to write that again using R squared because these are exponents, I'm not adding them. Now I would go ahead here and I would divide by 5, giving me 4 equals R squared. And R equals plus or minus 2. Why plus or minus? Well, I could have two different sequences. I could have 5 times negative 2, which is negative 10, times another negative 2, which is positive 20, and that works. Or I could have 5 times positive 2 times positive 2. So this works to have two different R values, which means I actually have two different resulting sequences. I need to have them both. Let's try the next. I'm going to say 54 is the result, okay, of starting at 2, and this time I've got 3 R values. Now remember, the way to find how many R values is actually to say that this is the first and this is the fourth. So I would subtract the 4 minus 1 to give me 3 R values, and I'm going to write that as an exponent, R cubed. Now to solve, I'll divide by 2 to get started, which is 27 equals R cubed. And when I take the cube root of 27, okay, which you can do by doing 27 to the power of, why did I do that? Anyways, 27 to the power of 1/3. This represents the cube root. Or if you know where the button is in your calculator, go ahead and find it. But the 1/3 power takes care of the cube root. And this will give me a result of 3. So my R value is 3. Could my R value be positive or negative 3? And the answer is no. Because if I did a negative 3, negative 3, negative 3, this would have been a negative 27 here, and it's not. Okay, so I'm going to change pen color so you can see me right in here. Then I'm going to multiply by 3 and get 6, and multiply it by 3 and get 18, and now I've completed my geometric means. Let's try the next one. Alright, I'm going to end with 1 because I started with 81, that's like my first term, and this time I'm going to say, well, if this is the first and this is the second, third, fourth, fifth, then I've got R to the 4th power. Now I'm going to divide by 81, but I don't want that decimal, it's not necessary. And then I'm going to say, well, I need to raise this 81 to the 1/4 power. Okay, so 1 to the 1/4 power, and that's going to give me a result of R equaling plus or minus 3. Once again, I'm going to have two answers because I will have both positive and negative 3 when you raise to the 4th power is 81. Alright, so let's go ahead and fill in the blanks on that one. And if I, oh, did I say 1? It should be 1/3, right? Silly me. That should be plus or minus 1/3 because I'm getting smaller, so I'm dividing. So this is going to be 27, 9, and then 3, or negative 27, then this one would still be positive 9, and then this one would be negative 3, and then I'd have a positive 1 to finish. So I get two different situations here because it's a 1/4 power. Alright, so we went through quite a few things here. We talked about writing the explicit again and then using the explicit to find a certain term. We can recap in class, or you can ask clarifying questions on Schoology about when to use decimals, when to use fractions, what do you do when it comes up and you can't turn it into a fraction. We definitely want to handle all of those things before we get to our next quiz. Also, making sure that we understand geometric means and that we're not using addition here. I'm not adding on these values. I'm using exponents to represent repeated multiplication because I'm multiplying by r, by r, by r, by r. So that repeated multiplication is important. All right, great job.